bit bigger. There you go. These are intermediate kind of problems. So don't feel bad if you can't do these. You're not supposed to be able to do these. I'm actually pretty impressed at how many of them you can do. You already have a pretty good foundation in general. Let's draw a picture. If you don't know where to begin, always draw a picture.
All right.
My other rectangle must be 2L. Or I could have labeled this 1/2 L and L. Okay.
Okay.
The width of rectangle A is 1/2 the width of rectangle B. So how can I label the widths?
You can.
In other words, if I label that one width, how big is this one?
1 second. 2W.
Okay. And it doesn't matter that I haven't drawn them accurately. Now, what is the ratio of the area of rectangle A to the area of rectangle B? Well, what's the area of rectangle A?
LW.
What's the area of rectangle B?
4LW.
What's the ratio of A to B?
1:4.
Good. That's a good thing to realize. In other words, if the length and width are half, but the area is 1/4. So it's not the same as the similarity ratio. We had a similarity ratio of 2:1, which translates into an area ratio of 4:1. Always. It's always the square of the similarity ratio. Okay, in the figure above, AD is parallel to BC, which we already knew because that's a right angle, that's a right angle. They have to be parallel. What is the perimeter of that quadrilateral?
So first, wouldn't you have to find AD with 360 equals, wait, no, that wouldn't work. Never mind.
Yeah, you're on the right track. You do have to, to find the perimeter, we need AD, right? If I had AD, I'd have the perimeter pretty easy.
We do need the area, though. Wait.
No, just need the perimeter. So how am I going to figure out AD?
Well, first of all, I would just, no.
Think about adding some lines to this figure. Where would I add a line if I wanted to figure out AD?
You would put one across from C to the top.
Right there. Yes, from C to the top. That's a good way to describe it. Well, what's the length of that line?
40.
Okay. If that's 40 and that's 50, now examine that little triangle. What is this distance right here?
30.
Very good. What's AD total?
280.
Good.
And you get
What's the perimeter?
640. Wait, no, sorry, 680. Wait, 620, yeah.
Okay. It's all right. Just testing your arithmetic skills there. They're not bad. Okay.
So,
tough one.
Isn't that,
So it's technically
one...
DC squared divided by GH squared, right?
Yeah.
In other words, the area of the big square is DC squared. The area of the little squared is GH squared. So, we need these things. Well,
wouldn't it be 1 to 2 actually?
Maybe, I don't know yet. What we need to examine is one of these little corner triangles. This one right here. And is that a 45-45 or a 30-60-90 triangle? Is it one of those special triangles?
It's a
45-45.
Yeah.
Okay, the dimensions on a 45-45, those are always equal because it's an isosceles. What's the hypotenuse?
That would also be one. Wouldn't it be just those two sides?
Square root of the sum of the squares.
Yeah.
So what is this?
So 1. Or
remember, it's the square root of 1 squared plus 1 squared. Okay?
Okay.
This is a good triangle for you to memorize. Don't forget this triangle. 45-45, 90 has these dimensions. Could be 10, 10, 10 root 2, but it's always in this relationship. Okay?
Okay.
So, if we look at the rest of our figure, there's D and there's C. How long is DC?
2.
What's the area of the big square?
2.
If DC...
Oh, sorry, not the big square. 4.
Okay. So the area of the big square is 4. They want the area of the little square over the big square. What's the area of the little square?
The area of the little square would be 2.
Right. So 2 over 4 is 1 to 2. How'd you know that?
I think I heard somewhere that if there's a square and it's in the middle of another big square like that.
Yeah, you're right. It is always 1 to 2.
Yeah.
Always 1 to 2. And there's another way to look at it. Let's look at it a little bit. That's the proper analysis. And notice that I made those numbers up. The big square didn't have to be a dimension of 2. The only thing I care about is the relative dimensions. So I made it whatever I wanted. I made it 1 to go from here to here. But let's think about this from a geometry point of view here. If I take any rectangle and I draw a line through it, a diagonal, it splits that thing in half. Always. Well, notice that if I take this figure, each one of these is the diagonal of, in that area, the small rectangle, or this part of the square is half of this quarter, right? Same thing in every quadrant. By a quadrant, I mean this part right here. That's quadrant 1. Well, if I shade in the little square, it's half of that. If I shade in the little square, it's half of that. If I shade that in, it's half of that. If I shade that in, it has to be half of that. Therefore, it is have to be a 1 to 2 ratio. And you can answer it conceptually like that without doing the math.
All right.
A little quicker. In other words, by knowing what you knew, you answered this in 5 seconds and you were correct.
Okay. Sweet.
How about here?
Would C be 25?
No. What is...
Wait, no. Sorry, never
All
mind.
right.
I just realized
All
what
right.
I was doing.
What's the side length of A?
Yeah, wouldn't it be 25 still?
What's the side length of A?
No. Oh, the side length. Sorry. I'm not thinking straight. It's 3.
What's the side length of B?
4.
What's the side length of C?
7, and so it's 49.
Okay.
Sorry, I was thinking that we were just trying to find 9 and 16 were the side lengths of.
Well, I wish all my stuff was this clear and with a nice white background like this. Okay. So we have a rectangular picture. It's 8 by 12. And they want to put a frame on it, surrounding it by 2 inches. So what's the area of the shaded region?
Oh, you would just add 4 to both sides, wouldn't you?
What's that?
And then multiply?
Huh?
You would add 4 to both sides and multiply?
Okay, what do you get when you do that?
8.
I did just say something about shaded area problems. What are all of them?
Oh.
They're
What?
always subtraction problems.
Okay.
We're
Yeah.
going to get the shaded area by the area of the outside rectangle minus the area of the inside rectangle.
Yeah. So I am right when I
Yes,
say
you're
we have to add 4 to
almost.
both. All right.
So let's proceed along those lines. So what's the area of the big rectangle?
It is 6. Wait, because you get 16 times.
That's an 8.
Yeah. 16 times 16.
You said add 4 to each.
What? Yeah. Sorry, I'm not thinking straight. Yeah.
Okay, 16 times 12 is the area of the big one. What's the area of the small one?
It is 96.
So let's see how to do this manually. If I take 16 times 10, I get 160. 2 times 16 is 32. It's 190.
Yeah.
Minus 96 is 96.
Yep.
That's rather amazing when you think about it. Is all we added was 2 inches to each side, and we have as much area in the frame as we have in the entire middle picture.
All right. Okay.
So we have a quadrilateral, which just means any 4-sided figure. And we've got A, B, and C equal to 2D. What's the degree measure of D?
All right. So you would have to make it 360 equals 3x plus 2x, right? Or something like that?
Something like that. Let's just use instead of adding letters, what do I know for sure?
A, B, and C are the exact same.
A plus B plus C plus D add to what?
Oh, equals 2D. Sorry, I wasn't looking at 360.
Right. In other words, all 4 angles have to be 360, right? And it's not a plus b plus c plus 2d.
Yeah.
All four angles have to equal 360. Now, I have another equation I can write. A plus b plus c equals 2d. So, where can I substitute in that first equation?
You could, wait. Well, first you would, wait a second, how would you eliminate the O?
What do you see right there?
That could be 3x or something like
Let's
that.
leave it in these variables. Let's not introduce any new variables. We got these two equations. We got a plus b plus c plus d equals 360. We know that has to be true. And they tell us that a plus b plus c equals 2d. So let's substitute here to solve this thing. There's the a plus b plus c. What can I write in there?
Oh, wait. I don't really understand what you mean by that.
Because it's a quadrilateral, we know that the four angles add to 360.
Oh.
Okay? All quadrilaterals, all four angles have to add to 360. They've also told us that a plus b plus c happens to be equal to 2d.
Oh, so you could do 2d plus
There
c.
you
Okay.
go. Let's substitute for that a plus b plus c. We'll make it 2d instead. And now we have a simple equation that we can solve. What's 2d plus d equals 360?
120.
Right. 3d equals 360. D is equal to 120. Okay? So I'm not sure if this was more of an algebra problem or a geometry problem. Probably more algebra, don't you think? In other words, the key was really seeing that you could substitute the a plus b plus c being equal to 2d for this a plus b plus c. Whenever you're trying to solve something like this where you got four variables, you better be able to get it down to one variable quickly. And we were able to. In other words, we could replace these three variables with a 2d, and we already have a d, so now we can solve it easily. The area is equal to 12. What is the perimeter equal to?
Well, could you turn it into any type of 4, 5, 6 equation?
No, that's not a, that's a rectangle, that's a triangle, for sure. But, in other words, we have our standard triangle.
Oh, yeah.
That's a perimeter that's 12. Oh, no, it says the area is equal to 12. Well, the area of this one's only 6. So I could double it. I could make it 6, 8, 10. Huh? Area of that's not 12 either. Area of that is 24. Now let's see. To get an area of 12, I could make that 4 and that 6, right? As long as that's a right angle.
Yeah.
Okay, so if I do that, this thing has to be what? Square root of what?
That would have to be the square root of 16 and 36.
52.
Yeah.
Okay, so there's a triangle that works. In other words, there's a triangle whose area is 12, and the perimeter is 10 plus root 52. Well, that answer's not on there. What's going on here? What do you think?
Well, I bet it's looking for a solid answer, so I think it's saying it can't be determined is the best thing.
Exactly. It's not a guess even. In other words, that perimeter was 10 plus root 52, right? Problem is that I can come up with all kinds of triangles that have an area of 12. What if I made that 2 and this 12? That also has an area of 12, and yet now this is the square root of 148. So this perimeter becomes 14 plus square root of 148. Gosh, I got two different answers. Both the triangles have an area of 12. It cannot be determined. If I can come up with two different answers, then there's no way to come up with precisely one answer.
Okay.
Now, having said that, if ever you're taking a standardized test, that is almost never the right answer. I've only seen one question in my life where that's the correct answer. And guess where it is? Right here. Okay? But this is not a standardized test. This is kind of a review of geometry. And this is actually a pretty good question because it forces you to think that, well, there's more than one triangle that I can draw. If the only condition they give me is the area has to be 12, well, I can draw all kinds of triangles that have an area of 12. And just doing two of them gives me two different perimeters. Therefore, it has to be 13. All right, let's see. I think that's the end of the page. Yeah, we'll hold 14 till the next time. It's not really difficult. In fact, let's do 14. No. It's a shaded area problem, so what kind of problem is it? How are we going to do 14 conceptually? We won't do it yet. How are we going to do it? The general plan of attack is going to be what?
We are trying to find...
Can take the area of the big square?
Yeah.
And subtract...
Divided the tiny square.
Exactly. In other words, it's a shaded region problem. Those are almost always subtraction problems. So it's merely the big square minus the two white squares. Well, that's actually pretty easy. The big square is 2x plus 1 squared minus 36 minus 9. Only in this problem, they give you the area and they want you to solve for x, but I just gave you an equation that lets you solve for x. So,
okay.
All right, we'll do 14 again next time just to review it. I'll make a note that we finished 13 on page 164. Now, let me write it down right here. 13 on 164. All right, good stuff. This is the way geometry should be taught. I'm serious. I really believe that. I think the way they teach it in school is terrible.
Yeah, they always teach you the
Well, they start out with the hardest stuff. They do. They start out with proofs, and proofs just demoralize everybody. And then a person is demoralized before they get to the easy stuff. So, anyway, so this is going to help you a lot. And we'll touch on proofs before we'll get through all this stuff before the end of the year. So we'll start on proofs before you take your geometry class. Okay?
All right.
All right, David. I'll talk to you next week.
Okay.
Bye.
Thank you.